The times per week a student uses a lab computer are normally distributed, with a mean of 6.5 hours and a standard deviation of 1.1 hours. A student is randomly selected. Find the following probabilities. A. Find the probability that the student uses a lab computer less than 4 hours per week. B. Find the probability that the student uses a lab computer between 6 and 8 hours per week. C. Find the probability that the student uses a lab computer more than 9 hours per week. What I've done is I've gone ahead and rewritten the problem's answers here, here, and here, or I should say copied in, because it's important to note that underneath each answer field my stat lab will indicate how the answer should be inputted into the answer field. In this case, we're going to round to 3 decimal places as needed. Now we have to understand exactly what's going on with this problem. We'll go back up to the original part of the problem, and we see that we're looking at the times per week a student uses a lab computer are normally distributed, which means that we are looking at a normal distribution. And table 4 in the textbook is used. Okay? And that is called the standard normal distribution table in the textbook. Now, let's further break this down. We have a mean of 6.5 hours. And a standard deviation of 1.1 hours. A student is randomly selected, and we want to find the following 3 probabilities. Remember that when we find the 3 probabilities, we are looking at the values that are within the body of the standard normal distribution table. Since the normal distribution is based upon z-scores, and generally speaking, and the corresponding values inside the table will be area under the normal distribution curve, they're also considered probabilities. So remember that when we're dealing with the normal distribution, we're looking at just roughing out what we call a bell curve. We do have a z equals 0 at the very middle. Okay? And then we're going to talk about areas. So when we talk about a z-score, we're going to use the following formula. Z will be equal to the x value, whatever it may be, minus the mean divided by the standard deviation. We generally round z-scores to 2 decimal places. Sometimes you can round them to 3. Once we find the z-score for each one of these particular probabilities that we're trying to find, we'll then go to the standard normal distribution table, and we will look for the corresponding area, which will be our probability. Now, when we look at the distribution table here, what I want you to understand is when we look right here where it says z, and then we look at the first 2 places in the z-score, and then this is going to give us the 3rd place as we move across the top. And we'll talk about that as I discuss the z-scores that we are going to calculate and how to find them in the table. So let's go ahead and look at part A, the probability that a student uses a lab computer less than 4 hours per week. Okay, to find the probability that the student uses a lab computer less than 4 hours per week, we're going to use the mean of 6.5 hours and a standard deviation of 1.1 hours, and we're simply going to put this into our formula z equals x minus mu divided by the standard deviation. Now our x value is going to be this 4 hours per week. So I can write this as x is equal to 4. And now let's discuss what the z-score will be. We'll have our x value of 4 Now we'll subtract the mean, which is 6.5, and then we will divide that by the standard deviation of 1.1. Notice that I am putting parentheses around the numerator, and that's how you need to enter this into your calculator. Many people will simply type in 4 minus 6.5 divided by 1.1. That's not necessarily going to follow what you want to do, because most calculators will follow the order of operations and do the division first and then do the subtraction. But by doing the division or the subtraction in the numerator first and saying 4 minus 6.5 is equal to a negative 2.5, and then dividing by the 1.1 in the denominator, we end up with a negative 2.27, and that's going to continue on. It is a repeating decimal. So ultimately, I'm going to round to this place value, the second place or second decimal place behind the decimal point, which would be hundredths. So my z-score is negative 2.27. And now we are going to find negative 2.27 in the normal distribution table. Okay, the first part of the z-score right here, the negative 2.2, will be found in this column, and we'll find negative 2.2 right here. Then we are going to look for this part, which is going to be 0.07. So we are going to be looking across the top until we find 0.07. So we're going to come down, and where these two intersect, that gives us the area under the normal curve. So if we had drawn our curve, and it doesn't have to be perfect because mine certainly isn't, and we know that z equals 0 is in the middle, but we're looking for a z-score that's a negative 2.27, which will be somewhere down around here. And we're going to be looking at all the area under the curve all the way out to negative infinity. And this value right here is going to be 0.0116. Now that's the area under the curve, but it is also the probability. And let's look at this in terms of how we would write this in mathematical notation. For part A right here, it says find the probability the student uses a lab computer less than 4 hours per week. So basically, we would write this as a capital P, which means probability, and X would be less than 4 hours per week. Now note that this less than sign is pointing to the left, so we'll be looking at area under the curve to the left of whatever value we come up with for a z-score. And once we calculate the z-score, we can also rewrite this as the probability that z is less than negative 2.27. And they're synonymous. They mean the exact same thing. So now that we've found this value, and we write down the fact that P of z is less than negative 2.27, we find that that is equal to the value of 0.0116. Now we're going to round this according to what my stat lab wants us to round the value to. And if you remember, and let's just scroll up a little bit, it says round to 3 decimal places for all of these values. So then we will go ahead and look at that and say, okay, where's 3 decimal places? When we round this, we're going to be rounding right here, and this value will increase that to a 2. We're going to round up, so this will be equal to 0.012. So the probability that a student spends less than 4 hours will be equal to 0.012, and that's the value that you will type into my stat lab. As I said previously in this video, you have to be very careful about how you input these things, and you will be told in the problem itself, and let me scroll back up to show you exactly what the computer or the program is looking for as far as how you're going to format your answer. All right, the next part of the problem states, find the probability that a student uses a lab computer between 6 and 8 hours per week. This is going to involve finding 2 different z-scores. We will need to find 2 z-scores, and we will need to subtract the area under the curve for the greater z-score, or I should say for the lesser z-score, from the area under the curve for the greater z-score. So as a quick reminder, remember that z will be equal to the x value minus the mean divided by the standard deviation. So in mathematical terms, we're looking for the probability that 6 is less than or equal to x, which is less than or equal to 8. And then we can also put that in terms of a z-score once we find the z-score. So as I said, we're going to need to find 2 z-scores. Z sub 1 will be related to 6 hours. So this will be 6 minus the mean of 6.5 divided by the standard deviation of 1.1. Go ahead and calculate that, and we get a negative 0.4545 repeating, which we will simply round to a negative 0.45. Then we're going to calculate the z-score for the second one. So z sub 2 will be equal to, and we're looking at a value of 8 here. So it'll be 8 minus 6.5, and we'll divide that by 1.1. And that will be equal to 1.363636, and that again is repeating, so we will round that to 1.36. So now we can go ahead and write it as a probability that we are looking for a z-score at negative 0.45 less than or equal to x, or I'm sorry, less than or equal to z, less than or equal to 1.36. So once again, we'll need to go to the normal distribution table. We'll need to find negative 0.45 and 1.36 in the table and come up with the corresponding area. Okay, looking at our tables, and I know they're kind of small, but I wanted to make sure that we could fit them in and we can see everything. A z-score of negative 0.45, that means we're down here at negative 0.4, and then we're looking for the column for 0.05. So our z-score is right here, or I should say our probability. So the probability that z is less than negative 0.45 will be equal to 0.3264. And once again, for the z-score over here of 1.36, we look right here for 1.3, and then we look right here for 0.06, and where the two meet, that is our probability. So the probability that z is less than 1.36 will be equal to 0.9131. But remember that we are looking for the probability that x is between 6 and 8. In other words, the probability that negative 0.45 is less than or equal to the z-score less than or equal to 1.36. So in order to do this, to find this probability, we will take the greater probability value, or area under the curve, and we will subtract from that the lesser probability value, or area under the curve. And that will be equal to 0.5867. But once again, we're going to round to 3 decimal points, so 0.587. And then we're going to finally do the third part of this. And just as a quick reminder about what we've done, if we draw the normal distribution curve, i.e. the bell curve, and we understand that we have a z-score at negative 0.45, and then we have a z-score at 1.36, the area between the two is what we're looking for, right here to right here. So this is everything between these two. Therefore, once we find the area for this z-score, which is right here, and then we find the area for this z-score, which is right here, but notice that it overlaps, we're looking for just the difference between the two. We want to get rid of everything that overlaps. So this needs to be subtracted out. And when we do that, we end up using this form right here. And remember, another way of writing this would be the fact that P, probability of 6 is less than or equal to X is less than or equal to 8. And that would be equal to the value that we just created right there. Alright, now let's move on to finding the probability that the student uses a lab computer more than 9 hours per week. Once again, if we look at this, this is what's important. It's more than 9 hours per week. So we want to find the probability that X is greater than 9, which means that we will have to subtract the value that we find in the normal distribution table from 1. But we'll explore that a little bit more as we progress. Now, reiterating that the mean is equal to 6.5 hours, and that the standard deviation is equal to 1.1 hours, and we're using an X that is equal to 9. So to find the z-score, we will take the 9, we will subtract 6.5 from that, the mean, and then we will divide that by 1.1, the standard deviation. And that will be equal to 2.272727, once again repeating decimal. So if I round this off, we have a z-score that is equal to 2.27. So once again, if we look at it from terms of the bell curve, z equals 0 is here, and we are looking at z equals 2.27. And remember that this is a greater than. That's what's important. So it's the probability that z is greater than 2.27. So instead of looking to the left, we want to find everything that's going to be to the right of the z-score. Hence the reason that we will subtract the value that we achieve for this area under the curve from 1. So the probability that z is greater than 2.27 will be equal to 1 minus the probability that z is less than or equal to 2.27. So let's go to the table and look up the area under the curve for 2.27. So once again, we look for 2.2 in this particular table, which is right here. And then we're going to look for 0.07, which is right here. and then we find where the two meet. And that's the probability for less than 2.27, so that would be 0.9884. But don't forget that we will be subtracting that from 1. So 1 minus 9.9884 will be equal to 0.0116. Once again, rounding to 3 decimal places, it's 0.012. So the probability that the z-score is greater than 2.27, or z is greater than 2.27, or the probability that the student spends more than 9 hours at the lab is 0.012. Once again, as I said, we've rounded to 3 decimal places.